So we finished looking at the grouping node type and group node. It's frozen twin sister, the static group node, and the transform node, which is our big workhorse. We also talked a little bit about coordinate examples. So I'd like to point out that we do have coordinate examples seen right in the examples for this chapter. So if we look at that guy, there it is. I can zoom in kind of handily here. I just used the wheel on the center of my mouse. Even when you're in examine mode, XJ3D will let you zoom in and out like that. That's pretty convenient. So we see XYZ relative to the origin. We can see that we still have this pesky text bug with the vertical alignment being off because the Y is getting swallowed up by the vertical axis. I can also see that this scene needs a little bit of updating. So let's see if you guys can spot what's wrong. Besides the Y, what is wrong with this picture? That's right, everybody's putting their hands up. That's the right thing to do, X, Y, Z. And let me reset the viewpoint. So we'll go to the home viewpoint, and we can see that X is to the right and Y up. Now I'll just zoom in straight and do nothing else. Okay, so we have X to the right, Y up, Z out of the screen. Now I'll rotate it to confirm that. Yep, Z is out of the screen. So what else is wrong? Okay, I'll tell you, because it took me months to see this, and we don't have that long on this tape. What's wrong is arrows on both sides. Okay, so we have another version of this scene. I'll drop in the update to get rid of the arrow points. In other words, the cones on the negative direction, so that we only have the arrow in the positive direction, emphasizing that X is positive x-axis. It's directional. The arrow on the other side, it's okay to have an arrow there, but then I would expect to have a label, which would be the negative x-axis. So it's maybe editorial, maybe a finicky point, but we'll get more and more precise. Okay, this is also a good example of how, hey, you can build useful, interesting scenes using only primitives and using transform node. Okay, so let's look at this. Do we know everything in here? Well, we know cylinders, cones, cheating at least, we've seen how to change colors on things, and we know how to do text. And the preceding lesson we learned how to rotate. So this is actually a good scene to expect. So I'll double click on the scene bar. It'll retract back in place, and now let's look at this scene graph structure. And maybe what I'll do is we could look at the source as is, or we could look at the XML tree. So let's open this up. So here we go, transform group, transform group. Then what do we have? Arrow red and arrow blue, and then some more good stuff in here. Okay. And oh, look at that, I forgot the first one. The initial group has the arrow green. Okay, so what else? We can look into that and say we keep seeing the same pattern, shape, cone, appearance, and then where's our material? We don't have a material there under that shape because it says use green. So green is our appearance node. So let's go back up here and say, well, look at that. The prior definition where we first defined the appearance node, green, does precede the use and does have a material in it. So when we did the def use on this example, we got the copy of the node plus all of its children, right where we wanted it. So if we said, well, maybe that green is just not green enough for our purposes. Here's a good trick question. We'll open up the material editor and say, what is the RGB value for marine green? Or at least olive green? Anybody? Just when you thought you knew everything about the Marine Corps, somebody has to ask a tricky. Let's pull it up, let's check. Well, we could mess around and find something here that's maybe a little more to our liking on green. Say when, or say what. Are we getting too yellow here? How about that one? That's maybe a little darker. Let's try that. Okay, so then when we hit OK, notice it's only changing in our local editor here. It doesn't change back in the scene. We have to first say OK, and then we're going to have to redraw it. If it comes back to me. Long, pregnant pause. Jeff, I think what's going on here, especially at the beginning, this usually happens near the beginning of the recording, and only when we're recording, so there must be some kind of file storage thing we're tripping on. It's doing some basic cleanup or something, I don't know. So we'll just have to wait it out. But maybe the key there is starting earlier on the recording and we've been trying to, and I'm just talking now because we're stuck. You don't want any of this on the tape, but it's not yet responding, and we expect it to. So if that's indeed the case, then maybe just starting the recording as early as possible, even while we're doing the other setup, will let it get past whatever hiccup is going on. It doesn't make too much sense though, so I'm not sure.
I'm surprised your new Dell can't handle the...
I am too. This is unusual, because and maybe I've somehow triggered some other problem here. That's another failure mode I have as an instructor. I'm trying to be, of course, very careful and precise when I'm interacting with the interface to show you guys exactly how to do it. But my focus of attention is in two places, so it's possible that I misdrag or click on something while I'm not looking, or that's all I can guess, The answer to the question, what did you do wrong while you weren't looking, is sort of like, when did you quit beating your wife or something, It's like, well, no good answer to that question. Yeah, don't anybody here try to answer that, please. Yeah. Okay, so when is enough enough? I exercise this tool at least an hour a day outside of class, maybe as much as some of you guys. And are you getting this kind of behavior? You do? Okay, so if you do, please tell me when, and if possible, what you were doing when it happened, so we can track it down. Try to find a common, because the whole key here is...
It's just this thing, it just...
Oh yeah, you have the...
I can't have Outlook and this running at the same time.
I see.
That'll cause me.
You have the Boston Computer Museum computer there.
I can never open your
Okay,
file.
I'm gonna kill it. Go ahead. Yeah.
While we're doing that, just so I completely understand the def and use. So basically,
Yeah.
the def, you'll define it up above, like we did appearance def equal to green, and then we have material right under there that you put in the numbers to define the actual color.
Yes.
And then once you use it on the bottom, it basically will copy that material line from above.
Correct.
Okay.
In fact, it doesn't even copy it is the way you might think of a cut and paste. It's a copy by reference, meaning it puts a pointer there. So every time, let's re-ask this question when we're taping again, but it reaches back and grab it. Or you don't have to ask it, I'll just answer it when we
Yes, sir.
go there, yeah.
Also, when we're looking at the previous image, we had X, Y, and Z. Are we looking at rays or are we looking at just lines? Where we want to go from negative infinity to positive infinity, either X, Y, or Z direction. And the other would just go from 0 to, or from a predefined start point to a predefined end point.
Well, for one thing, it's not going to infinity because we just had it, it goes as far as you tell it. You have to give it values. So we don't have a way to specify an infinite geometry. It's always going to be some finite value. And then second, what was the other question?
It was all tied to the same question, whether we're talking about, is it an array or is it a segment that we're looking at?
Okay, those are all geometry nodes that we've seen before. So they're cylinders that originate at the origin. Ken, go ahead.
So if we're going to do like a bunch of defs, as far as coding style, do you want those like all at the top? I know in some of the other languages it said we use like a whole bunch of constants. Do all your definitions in one place just so it's easier to...
No, we sprinkle them out through the scene, actually. And you just do them where they make sense. And the definition, if you're going to have multiple copies of it, the def goes in the first. So that's about the only where do I put it question that we have. Those are all three good questions that I should probably do on camera. I think we're just about restored here. Did anybody find out the RGB value for marine green yet on the official website? Or there's we'll see in the next chapter. I've got a table in there of all the HTML colors, and we can pick from there too. Okay, so where we were was we adjusted the color, so I'll do that. And this time I'll simply make it a little darker by going 3/4 on everything. So that's just like adding some blackness to it. Okay, so we finished editing, and now we're going to look at the color change. So we'll restart the viewer. I'll zoom back in. Say, well, looks about the same. Maybe we'll make it slightly darker yet again. We get to the right node. I'll select that material that's under the green appearance, and then I will edit it, and then we will make it just a little bit darker. Okay. And then redraw. Slightly darker. I probably should have gone to another color, but it's a little hard to tell on the screen. But there you go. That's how you do it. Okay. Now, some things to pay attention here are, it doesn't much matter what order you put nodes are. You don't have to group all the defs at the beginning, for example. You can just put them where they're naturally going to belong in the structure of the scene graph you create. But if you're going to have multiple copies of it, the def version goes first so that the used versions can follow. All right? And that's why the used green here appears after. Then further, when we say the word copy, we should be precise or think about it, how it works. It's not a copy like a cut and paste. It's a copy by reference. Namely, you're copying a pointer, you're copying a link back to the one it's supposed to use. So that as the graphics card goes through this and says, all right, I've got some geometry, I've got the material, I've got, I've got geometry, I've got the appearance, I've got the material, there's the first one. Then it comes to the next. I've got the shape, I've got the geometry, I've got the appearance. Oh, this appearance is a copy by reference. It's a use. So I go back up to the def, grab that guy, read it as part of my rendering, and then pick right back up where I was. And so that's how the hardware and the software that wraps it deals with that thing. So it is more efficient. It's not creating multiple copies in memory. It's merely allowing one to point to the other. Saves memory, saves performance in that if that chunk changed, you don't have to recompute anything. And so just works faster. Okay, now I could see a further flaw in this example. We've modified it a few times over the years, and that would be a naming convention issue. We've got appearance, use equals green. Well, what if we weren't sure when we were using that node whether it was an appearance or it was a material? Right? Does the word green tell you which one it is? Answer, not particularly. So maybe this would be better to change green to green appearance so that it was unambiguous. So there's a hotkey for that, Control H. You can also get to that through the menu. So we'll just look for whole words, green. Found one, so let's replace that. Found the next one, we'll replace that. There we go. Similarly for red and blue. And let me check my work there, make sure that the red went. Red appearance, there's the def. Okay, so now we'll look for whole words for blue and change that to blue appearance. Okay, so replace, replace, replace. Good to go. All right, so how does that match our naming rules? Well, it answers the question, you know you have the right name when you don't have to talk about it anymore. Okay, there I was just talking about it a second ago, saying, well, was that green an appearance, or was it a material? Or was it a pair of socks? It could have been anything. So the word green just by itself wasn't precise. So I often find myself, the names that I use typically will start with what's the functionality you care about, in this case green, and end with the name of the node that's there. So when you get it in a pull-down list or when you're searching for it, it's easy to find. So I could offer that suggestion to you. Your mileage may vary. Some people use the naming convention from the earliest days of virtual reality modeling language. Most people then were using all capitals, all capital letters, because they stand out. None of the nodes are all capitals, and as soon as you see that, it's sort of an indicator that, oh, this is an ID, this is a label, this is a def name, rather than that. I don't like all capitals so much because, one, well, I think most people, even our parents know that all capitals is like you're shouting at someone. But another reason why I don't like all capitals is because it's hard to string words together and have them readable Camel Case is superior for that. It's more readable in practice. And I learned yesterday about one of Newton's laws that I'd never heard of before. It was called Newton's Law of Experts. Did any of you hear this in the final session? Yeah, Newton's Law of Experts is for every expert opinion, there is an equal and opposite expert opinion. So what would be the equal and opposite to using all capitals and multiple words? Well, some people would say, well, that's okay, we just put an underscore character in there, or maybe a hyphen character. All right, well, that might work for some people, but hyphens are a bad practice because they also look awfully similar to the mathematical operator, minus sign. So if people are creating code out of your content, that can sometimes trip it up. Underscores, they look benign, helpful enough, but if you turn those into URL links, the minus signs disappear usually in an HTML page. If we pretty print this guy and see an HTML link, if there's an underscore in that link, it's just covered up by the underscore of the link. So it doesn't hurt us here in the tool that we're using, but some of the places our content might go would clobber it. Okay, because then when you're looking at the link, you can't tell, is that a space character or is that a hyphen in there? So that's why Camel Case is where we've landed. And how do we know that we have the right naming convention? Well, because we pretty much don't talk about it anymore. We've been building lots of content and it seems to work. Here's some examples of old naming there, capital letters and underscores. So you'll see a lot of that in legacy content, but I think it's a practice that people don't do so much anymore. Okay, so that was our coordinate thing, and we can see in each case you've got a set of transforms with translations and rotations. And what those do are, we can pretty much just figure it out, right? What would the rotations do? Well, the rotations would take each cylinder, default cylinder is straight up and down, and would rotate it sideways, either to get to the x-axis or get to the y-axis. Let's take one of those and test it out for ourselves. Okay, the arrow green cylinder has no transform on it. Does that make sense? Yes, the answer is yes, because the default cylinder orientation is straight up and down, so that matches our y-axis. Okay, and then what about our cone? Well, we could see that we used a translation to move the cone up to the top of the arrow, and we kept everything on this scene is 1 meter in each direction. Okay, so we moved the cone up 1 meter, we adjusted its width and height so it would be the right size to sit as an arrow at the top, and then we could reuse the green appearance, and if we ever change it, they all change similarly. Okay, then same thing again for, there's our Y label on the text. Then we have the same thing for the red, only this time we can see that the whole construct gets rotated 0, 0, 1, negative 1.578. So let's see, this is going to be our red, our X. So if the cylinder starts at the vertical as it faces the camera right now, and we want to rotate it this way, then the question is the XYZ negative 1.57 correct? Answer, let's check. So my left hand gets put away safely in my pocket or just holding this, and we get the right hand and we go, okay, XYZ, there we are centered at the center of the geometry. And if we want to go this way, rotate from the vertical down to the x-axis, and yes indeed, we're rotating across that, about that z-axis coming out of the middle. So now I pull my hand away, nothing up my sleeve, put it back, pointing along that z-axis where we want to rotate, we can see the direction of positive curvature. So if I want to rotate clockwise, then that's opposite the rotation. So that's why we have a negative 1.57, 1.57 being half of pi, pi being 180 degrees, half of a 2 pi circle. So 1.57, oh yeah, that's 90 degrees, so negative 90 degrees. Now for this scene, you might say, well, you know what, that's good, but I don't care. I could just as easily rotate 90 degrees the other way because the axis I'm drawing is symmetric, the green, the red axis. We go, well, yeah, until we take off one of the arrowheads, and then all of a sudden it matters again. Okay, so it never hurts to go through this exercise and test it out. Where is my origin? Where is my local coordinate system, x, y, z? What axis am I rotating about? Point your thumb down that axis, and then go, am I positive, am I negative? Okay, so this is a great scene to test that because you have several examples in several directions, and you can confirm how they work. It also lets you see right off the bat that, oh, when we translate the arrows and we rotate them, that's nested. That's in the same coordinate system as the parent. So what do I mean by that? Well, let's rotate the red axis, the X arrowing label, not quite as much. Let's just go 1.0 and see what happens. Something's definitely wrong here with my browser. Let's view it externally. Okay, we're trying it now in the new version of Instant Reality. And we can see, all right, there are axes, but this time we only rotated 45 degrees. Now see, I changed that 45 from 90 in just one place, but several things changed at once. The cylinder, the two cones, and the yellow X. Okay, so that's a good example of nested coordinate systems where as soon as you do one translation or one rotation, everything underneath that in the scene graph gets affected the same way. Okay, so if I fix that back again, undo, hit save, hit reload, we could see there it goes back. If we just wanted to rotate something else by itself, we'd have to go down to where it was. So let's see then, for our arrow cone, if we look at the translation rotation of one arrow cone versus the other, we have one for the green at the top of the screen, we have one for the red at the bottom of the screen. Oh, they're the same. Look at that. Those two cones aren't the same. One got flipped around at the top to align with the cylinder. One's getting flipped around on the side to get it to the cylinder. Oh, but they're not happening up in global coordinate system. Each one is nested. So you can say that's a local coordinate system. If the relationship between the cylinder and its cones is always going to be the same, regardless of which direction I'm at, then let's get that first sub-pattern right first, and then we can repeat it. You might even say, well, if it's all the same each time, let's just def and use them. Define it once, a cylinder with a pair of cones, or a single cone, and just do that once. Good idea. However, in this case, it won't work. Reason being, we have different colors associated with the geometry. Okay, so the way we've chosen to do this, shape always wraps the appearance in geometry. So if you want to copy a shape, you will always have the same geometry with the same appearance. Okay, so that's why we said some things we could def and use, the appearance goes, Other things, oh, we can cut and paste. And then just replace which materials those guys are using. And that's why you can see the same sub-patterns in here, and that's a good thing, because it makes your scene easier to author, easier to debug. Gosh, who would guess there'd be so much stuff in one scene? There's one more look ahead in here, a little gotcha that's kind of interesting. Notice how when I move the camera around, that the letters keep facing us. Isn't that handy? I can't see, look at the Y, for example. Here in Instant Reality, we see the text vertical is correct. And even though I'm spinning this guy around, the Y keeps staying next to me. So does the X and Z. So it makes our scene text much more readable, even though we're maneuvering around. Now I can still fake it out. I have this stuff rotating about the vertical axis, so if I get above it, then, oh, well, it's confused now, and you can sort of see, and it's trying to face me, but it's swinging around a pivot, vertical pivot, so it can't quite follow me as I get up above this thing and look down on it. So what node accomplished that for us? You might have noticed it earlier when we went through the tree. Down at the bottom where the labels are, there it is, a billboard. Okay, so the billboard is another one of these grouping nodes. And we'll cover that in the viewing and navigation chapter. We'll look at it in more detail. But just by basic inspection here, you could go, well, this couldn't be simpler. I just slapped a billboard in as my grouping node parent, and suddenly this guy pivots to match me. That can be a very helpful technique sometimes. Other times it's completely inappropriate. For example, if we put a billboard above a cylinder, it looks like a cylinder. Because you rotate a cylinder about its axis, it's still a cylinder. So sometimes it's helpful, other times it might be useless or even counterproductive. So we'll learn more about it in the later chapter. But I think we can safely troubleshoot and mess around. Go ahead and make your own changes to this scene. Test it out. Get that right hand working hard. Make sure you feel comfortable that, yeah, there's nothing in here that could get away from you, that you could track it all down. Okay, now I am going to, I think I'm about to do a little cleanup here. Let's try to get our palette up. That pesky palette has gone into hiding, so I'll go down to this menu item here, reset windows, and see if that brings us back to where we want to be. Do we want to get rid of our collaboration session? Yeah, that's okay. Or no, let's see if it survives here. Okay, so what did we get? We got the X3DV palette back up, because I had that installed by default. That's the one for classic vermilion coating. We don't have to worry about that. That's an extra feature. Click here to the X3D palette. For our notes today, could you please add, let's rename the palette to X3D palette so that we can distinguish it when multiple palettes are present. And the other thing from before was recheck the coordinates scene to make sure that's up to date with a single cone on each end.
Actually, I just got kicked out of the chat. So,
Okay. It's okay to keep the notes in a separate window and just paste them into the chat when you're there, or mail them at the end if worse comes to worse.
maybe I'm still
Russ, when I posted a file, I don't know, you should see at the top there,
Oh, great.
that's what that cone's gone.
Thanks. Yeah, well, let's look at that. Here in the chat room, we've got a scene posted. If I click on that, then now I'm looking at the shared coordinate axes. And did you make any changes to this guy that we can deduce?
Moved the Y up and took out the end cones.
Very good. Move the Y up so it's corrected and got rid of the end cones. So that's very helpful. The rest of you who are on chat for this session ought to be able to grab it and click on it and look at it too. Now, for long term, why don't you please mail it to the class list, because after we're done playing with it here, because that way it'll persist. The chat room gets destroyed when we all leave. And gee, this is better than the movies right here, right? You can send stuff around and we can all play with it live. We're not locked to a single viewpoint. However, there is one more gotcha on this guy. It's good that you fix the Y. It's now readable. However, if I launch this scene in another browser, again, we'll try Instant Reality out today. This is by the Fraunhofer team in Germany. Now look at the Y. Well, it was just right on XJ3D on the left. It's too high on the right. Okay, this is where conformance among browsers is so very important, and the Web3D Consortium and lots of volunteers work very hard to try to make that better. It's tricky though, because these companies are all different and they got their own agendas and their own priorities. So my advice to you is, if you find a bug, let's drill down and touch bottom and find out what it really is, and then we'll post the bug, make sure the right software gets the right error, and we'll leave our content compliant, even if it looks bad, in our tool of choice. So we might be walking around with a limp, but we'll be walking the right way and getting better. And then we yell at these guys, or cajole them, or send them 5-pound bags of coffee, whatever it takes to get it done. Sometimes we just jump into the open source ourselves. If I were working at the company, if somebody from one of the companies were here, they would add, and you could send us money. That helps too. So if you're a program manager in charge of your own project someday, that might be an option too. Now this does remind me of one of my very worst jokes, and I'm a little afraid to put this one on camera, Jeff, but we'll see. We'll try it out here to see just how bad you guys think these guys is. So here we have the situation. On the left side is one way, and the right side is the other way. And what do we do about it? Well, it reminds me of the story of the old man with the crippled hand, and he goes into the house of worship. You know, you could fill in temple or cathedral or whatever you want. He goes into the house of worship with the crippled hand, you know, and he's walking real slow. And he gets there and says, "God, oh God, make my hand like the other hand." Okay, so you know, I recommend you never tell that joke, because it's too upsetting in too many ways. But it illustrates this issue. You know, when we have one's not working, what do we do now? We got to fix something. And so the best advice then is do the right thing, make it right to the spec, make it correct as X3D says it should be, and then we fix the real problem, which is who's drawing it incorrectly. Okay, so we've reset. We've got our palette back. Geometry primitives, all done with those. We're in grouping. So what is our next grouping node? Let's get the favorites reopened. And there it is. It remembered where we were. Okay, there is one more coordinate axes example that we could look at. And let's pull that up. And you notice in the 3D viewer, it looks just the same. But what it's illustrating here is the inline node. The inline node lets you pull in content into a scene graph and have it end up right where you want. And you can see where we wanted it here was, let's make it bigger, because the original coordinate axes, when we looked at that, see, they look pretty small on the screen from the default viewpoint distance. But when we go back to this one, it's twice as big in each direction. So that might be better for the scene you want. So how big is big enough? Well, that will always depend. This is why we made this scene a unit length in each direction. 1 meter up, 1 down, left, right, forward, back. So it's 2 meters overall, but it's a 1 meter distance. Each one of those is a unit vector. So therefore, if we inline it into another scene, we already know how big it is. Don't have to think about the scaling. We just go, okay, I'll make it as tall as I want now. Of course, you would want to use a uniform, consistent scaling here, and that way it'll be the same. If we look at that transform node, our current topic, we see, oh, sure enough, there it is. Scale is right there, 222. Okay, which I think brings us full circle back to our slides. And we see now, how do we reuse that coordinate example? Oh, it's the inline node. Okay, so what does it do? It loads within the current scene. What does within the current scene mean? It means right there in the scene graph, wherever you put it. What formats you have are listed there. Typically that's .x3d and .x3db. It might also be the compressed binary encoding x3db and maybe even Vrmel97, which is .whirl. That depends on the browser. And so it drops in right at the current coordinate reference frame, and that's where it stays. So the only real gotcha here is that you do not change your viewpoint automatically to where any inline viewpoints might be. It stays in the viewpoints from the parent scene, if any. Okay, so I think that's our good breakpoint. On the next session, we'll pick up with URL field and how that makes the inline work. And the short story is we get to have more than one address instead of just one, and that's a good thing. See you next time.